students, Assalamu alaikum. We already have discussed about numerical 12.1 to 12.6. So now we discuss numerical 12.7. So we read the statement. Nabila uses a concave mirror when applying makeup. The mirror has a radius of curvature of 38 cm. What is the focal length of the mirror? Nabila is located 50 cm from the mirror. Where will her image appear? Will the image be upright or inverted? So dear students, the data that is given, radius of curvature is r is equal to 38 cm and distance of object from the mirror is 50 cm. So we need to calculate focal length, distance of image and nature of image. Clear? So to find the focal length we use the formula f is equal to r over 2, and to calculate distance we use the formula 1 over f is equal to 1 over q plus 1 over p. So first we calculate the focal length, that is f is equal to r over 2. After putting the values we get the focal length, that is 19 cm. Next we calculate the distance of image from the mirror. So dear students, the formula is 1 over f is equal to 1 over q plus 1 over p. So we need to calculate 1 over q, so formula will become 1 over q is equal to 1 over f minus 1 over p. After substitute the values we get final result, that is q is equal to 30.64 centimeter. Okay? Now we discuss nature of image. As q is positive, so image formed will be real, inverted and smaller in size than the object. So dear students, now we discuss numerical 12.8. An object 4 cm high is placed at a distance of 12 cm from a convex lens of focal length 8 cm. Calculate the position and size of image. Also state the nature of the image. Dear students, in the statement we have given about the height of object, that is HO is equal to 4 cm, and we are given distance of object, that is P is equal to 12 cm, and focal length F is equal to 8 cm. As we use convex lens, so convex lens is a converging lens, its focus is real, so its focal length will be positive. So dear students, we need to calculate the position of image, that is Q, and size of image, that is HI, and the nature of image we need to calculate. So dear students, we use the formula 1 over f is equal to 1 over p plus 1 over q to find the distance of image from the lens, and to calculate height of image we use the formula hi over ho is equal to q over p. So dear students, now we calculate distance of image or position of image. So we use the formula 1 over f is equal to 1 over p plus 1 over q, or 1 over q is equal to 1 over f minus 1 over p. After simplifying, now we put the values and we get the result, that is q is equal to 24 cm. As it is positive, so image is real. So dear students, now we calculate the height of image. So for that we use formula hi over ho is equal to q over p. Ho is multiplied by q over p when we shift it into on to other side. So the formula will become hi is equal to q over p multiply ho. So after putting the values we get the result, height of image is equal to 8 cm. So now we discuss the nature of the image. Dear students, since the lens is convex and size of image is larger than the size of object, Therefore, image formed is real, inverted and magnified. Right? Dear students, now we discuss numerical 12.9. An object 10 cm high is placed at a distance of 20 cm from a concave lens of focal length 15 cm. Calculate the position and size of the image. Also, state the nature of the image. So, dear students, we are given size of object, that is HO is equal to 10 cm, and the distance of object from the lens is 20 cm, and focal length is equal to 15 cm. As we use concave lens, so focal length for the concave lens is negative, so f is equal to minus 15 cm. Right? Dear students, we need to calculate position of the image, size of the image and nature of the image. So dear students, we use formula 1 over f is equal to 1 over p plus 1 over q to calculate the distance of image from the lens. So after simplifying the formula, we get 1 over q is equal to 1 over f minus 1 over p. After putting the values, we get the result, that is q is equal to minus 8.57 centimeter. It means q is negative, so image is virtual. So dear students, now we need to calculate height of image. So hi over ho is equal to q over p, and after simplifying we get the formula hi is equal to q over p multiply ho. By putting the values, we get the result, height of image hi is equal to 4.28 centimeter. So dear students, now we discuss the nature of the image. Since the lens is concave and object is larger in size than the size of image, therefore the image is virtual, erect and diminished. So dear students, now we discuss numerical 12.10. A convex lens of focal length 6 cm is to be used to form a virtual image 3 times the size of the object. Where must the lens be placed? We need to calculate the distance of object. So dear students, we are given that focal length of convex lens is 6 cm. So as convex, we take the focal length of convex lens as positive, so f is equal to 6 cm. Dear students, q is equal to minus 3p, because virtual image 3 times the size of the object. So it means distance of image will be 3 times of the distance of object, that is 3p, as distance is image is virtual, so we take the distance of image as negative. So q is equal to minus 3p. q is equal to minus 3p. Okay? Now dear students, we need to calculate the distance of object, that is p. So dear students, we use the formula to calculate the distance p, that is 1 over f is equal to 1 over p plus 1 over q. Right? Dear students, after putting the values, we get final result, that is p is equal to 4 centimeter. Is that clear? Okay. Dear students, now we discuss numerical 12.11. A ray of light from air is incident on a liquid surface at an angle of incidence 35 degree. Angle of incidence is 35 degree. Calculate the angle of refraction if the refractive index of liquid is 12.5. Also calculate the critical angle between the liquid-air interface. Dear students, remember that ray of light from air is incident on a liquid surface. Light ray enters from rare to denser medium. So we use the formula of refractive index, that is n is equal to sin I over sin R. When light ray enters from rare to denser medium, then formula is n is equal to sin I over sin R. So we are given data, so we discuss Angle of incidence is equal to 35 degree and refractive index is equal to 1.25. We need to calculate angle of refraction and also critical angle. Dear students, the angle of incidence at which a refracted ray makes angle of 90 degree with the normal. It means that angle of incidence for that refracted angle is 90 degree. So that is called critical angle. It means we need to calculate angle of incidence for that angle of refraction is 90 degree. That angle of incidence is called critical angle. So there are two questions in one statement. So we start. Next देखें, we calculate, first of all we calculate the angle of refraction by using the formula n is equal to sin I over sin r, and after that we calculate critical angle. For that we use formula sin c is equal to 1 over n. So n is equal to sin I over sin r and sin r is equal to sin I over n. After putting the values we get sin r is equal to 0.456. We need to calculate r, so taking sine inverse on both sides, so angle of refraction will become r is equal to 27.13 degree. So now we calculate critical angle. We know that the angle of incidence for which angle of refraction is 90 degree is called critical angle. We have value of refractive index n 1.25 already discussed, and angle of refraction will be 90 degree. So sin r will become 90 degree and we use formula sin c is equal to 1 over n. After putting the value of n in the relation, we get the critical angle 52.13 degree. Next, dear students, we discuss numerical 12.12. The power of convex lens is 5 diopter. At what distance the object should be placed from the lens so that its real and 2 times larger image is formed? So we are given that power of lens is equal to 5 diopter and size of image is equal to q is equal to 2p, because image is 2 times larger than the object. So distance is also 2 times larger than the distance of image also 2 times larger than the distance of object. So we need to calculate distance of object. For that we use the formula, that is 1 over f is equal to 1 over q plus 1 over p. So first of all we calculate focal length. We know that power of lens is equal to 1 over focal length. So this is the formula of power of lens. So after putting the values we get the focal length, that is 0.2 meter. Okay. So after converting focal length into centimeters, we get focal length is equal to 20 centimeter. Now we calculate distance of the object from the lens. So we use the formula 1 over f is equal to 1 over q plus 1 over p. After putting the values, we get the result, that is p is equal to 30 centimeter. So dear students, these are the numericals from 12.7 to 12.12. So you have to do homework of numericals and do practice 2 times or 3 times to memorize these numericals. So dear students, take care of you. Allah Hafiz.